So let's start. Hey everyone, welcome, shalom. We're very happy to be here. My name is Ben Klieger. I'm a lead PM from the Azure Security Center product management team.
My name is Zvi Ben Sheffer. I'm a PM on the Windows Defender Advanced Web Protection team.
Thanks for coming. It's last day of the conference, so we appreciate it. Today we're going to talk about server protection in the cloud, on-prem, other clouds, with Azure Security Center and with Windows Defender ATP. So let's start. So just in terms of scoping this session, we're going to start with a brief overview of cloud security, right? Some challenges that we're seeing, that we're identifying. We're sure that you'll agree with us. Then we'll deep dive into Azure Security Center and also include the integration and the new server protection suite that we have with Windows Defender ATP. Let's deep dive. We'll have a lot of demos during the session. We'll also try and leave some time for questions at the end. So, of course, if you have questions and you don't want to forget them, just write them down and we'll take them all after the session. And so let's start with cloud security. And of course, when we talk about cloud security, we need to remember the shared responsibility model. And what does that mean? As a cloud provider, Microsoft is doing a lot, right? You've been here this entire week. You've heard how many controls we have in place, the budgets that we spend on making sure that Azure is secure. And that, of course, includes processes, controls, and of course, manpower that are doing physical security, data center security, and of course, we're making sure that Azure as a cloud infrastructure and the services themselves, right, that we develop are secure and follow best practices. Having said that, when you move to the cloud, when you start moving your workloads to the cloud, whether these are IaaS, infrastructure as a service, right, virtual machines, or services like SQL databases that you can consume in Azure, storage accounts, Key Vault, basically what's not, every service that you can consume, you also have your own responsibilities that you need to take in order to make sure that those services are protected. Of course, that changes, right, as you move up the stack from IaaS to PaaS and, of course, then to SaaS, right? As you move up the stack, more responsibilities, of course, move to us as a cloud provider. Hybrid cloud, we're talking about multiple cloud environments, right? We have Azure, we have other players in the market, and of course, on-prem data centers, servers that you already manage today, will disappear someday, right? But they are still here right now. And this new environment, this new hybrid environment makes us facing new challenges. First, and that's one of the biggest advantages of the cloud when you think about that it really empowers every user in your organization to achieve more, right? Because every developer can spin up new VMs whenever it wants to, can remove those, it can then move from IaaS to a specific service. And basically, it means that the environment keeps changing, right? And we're talking about cloud speed, changing environments. How do you make sure that those environments that you have are compliant with the security policies that your organization defines? How do you make sure that those services, that those servers, VMs that are being deployed are protected? So that's the first challenge. Second challenge, of course, and we have a lot of former hackers, right, that have visited Ignite in the last week. They don't really care. Hackers don't really care where you run your workloads. On-prem, public cloud, the attacks are still there. They're getting more and more sophisticated. And of course, that going back to the shared responsibility model, when you are moving your workloads to the cloud, servers to the cloud, unless you have controls in place, those are usually internet-facing, which you can say make them even more vulnerable, right? So you need to make sure that they are protected and you have controls in place. Third, and of course, we'll all agree with that as well, there is a lack of security knowledge and security expertise in today's world. Environments are getting more complex, the attacks are getting more sophisticated, but we don't have the manpower or the knowledge in the world to handle that. So we need products that simplify things, that help you do things in an automated fashion, and really take this burden away from the existing manpower. So with that, we'll talk about Azure Security Center right now. Azure Security Center is the product from Microsoft that does infrastructure security. When we talk about infrastructure security, we're talking about data center security. That includes IaaS, PaaS, and of course servers, right? Which you can sort of say that there's a sort of an IaaS, right? A VM is basically a server, right? That you manage in your own data center. So Azure Security Center does protection for servers, virtual machines, and for Azure services. And what does that mean when we say that Azure Security Center does protection? First, we assess the environment in a continuous way. We discover the services that are keep being deployed all the time, the servers, the VMs that are monitored by Azure Security Center. We assess them against a security policy, best practices security policy as defined by Azure Security Center, as defined that is recommended by Microsoft, to make sure that those services, those servers that you have, comply with the security policies. That forms up in recommendations that Security Center provides you. Recommendations are hardening action items that we strongly recommend to follow. For example, when you have a server deployed on-prem, right? Azure Security Center will assess it to make sure that all of the patches are in place. And when a patch is not in place, Azure Security Center will notify you about that and will provide you with the means to mitigate that specific vulnerability. And we're doing a lot of more things, not just for Azure services, but again, very focused on servers, on VMs, and that's what we'll keep on talking on later today. So the first is security posture management and assessment. Second area of responsibility for Azure Security Center is protection against threats. And that's really where the better together with Windows Defender ATP also materialize. We have a very advanced pillar for threat detection. Threat detection alerts coverage in Azure Security Center across services and servers, of course. And third, we go back to the challenge that I've talked about with lack of security expertise, this lack of knowledge in the world today. Everything is being done in lightweight speed. Very, very fast. You don't need to be a security expert in order to work on Azure Security Center. Everything is being shown with guided user flows. Click here, click there, mitigate it within seconds. And that's what we're doing, okay? So now what I'm going to do, I'm going to show some more slides about Azure Security Center. Then we'll also do a deep dive just on the server protection suite that we have. And of course, it will all come with relevant demos. So the first thing I've talked about security posture management and assessment that we do. The first thing that you can do with Azure Security Center is to manage security policies, identify those gaps that you have in your workloads. If you have services that are not secure according to those best practices as are defined by our service. And you also get a coverage state and a compliance score for those subscriptions in Azure, for those policies that are in place to help you better understand how your workload looks like from a security posture perspective. Next thing, of course, as I've said, everything is being done in cloud speed, very, very fast. The environments are being assessed continuously. When the servers are already there, when they're removed, when they are now being spun up again, when a new service is being deployed, Azure Security Center will discover that immediately, and based on the security policies that are in place, will assess the environments all the time whenever something changes, and will notify you when something changes, and when there's a deviation from the security policy. More than that, we've heard a lot about Secure Score during the last week. Azure Security Center now also provides security score for all of those recommendations, for all of those hardening action items that we provide that basically come to help you prioritize the work. Which recommendations are more important than other, and which recommendations, which which action items that you need to follow will best improve the security posture of your environment. So that's about Secure Score. More than that, clicker can work better. More than that, we provide a lot of visualized capabilities to understand how your environment looks like. So we have introduced now in a public preview this new network map that provides visibility into your topology in Azure with security overlays on top of that. Security insights, those recommendations that I've talked about that are provided by our service to help you better harden your environments. That also, of course, includes a view into traffic analysis that we're doing. So we have a lot of offerings around network security as well. Last thing before we dive deeper into the server protection suite of Azure Security Center and Windows Defender ATP. I've talked about the threat detection pillar that we have. Basically, Azure Security Center for that is the single pane of glass for all of the alerts that are generated, that are detected actually in your environment for your IaaS, servers, and PaaS. All of these alerts come with a severity, come with confidence score that help you, again, prioritize the work, understand which alerts require your immediate attention. And of course, we provide full description and remediation steps to those alerts that help you act upon them fast and mitigate a threat. Last thing I would like to mention is this new integration that we also have in place right now with Microsoft Cloud App Security. I assume that some of you here are familiar with this product. What we're doing now with Microsoft Cloud App Security is that we have user and entity behavioral analytics capabilities, threat detection capabilities for activity within Azure itself, right? So we now profile the activity in Azure, which users create resources, modify stuff, all of that. We profile that, and then based on that, we also do anomaly detection that basically at the end resolves with threat detection alerts also in Azure Security Center. So again, it's a single pane of glass for all of the threat detection activity that is detected by Azure Security Center, by first parties that we have integration with, or other security products that you can connect to Azure Security Center. All of the alerts are being shown in Azure Security Center and are investigated and can be drilled down from there. With that, let's now focus on server protection and what we can do with Azure Security Center and with Windows Defender ATP. As you can see, these are the full stack of capabilities that we have today already available for servers, on-prem, other clouds, Azure, of course. These are features that you can enable and use in order to make sure that your servers are protected. And let's start. So first, when we talk about Azure servers, when we talk about Azure virtual machines, we need to understand that Azure Security Center is a native service. It's part of the Azure platform. That means that whenever a new VM, a new server, right, is being deployed, first thing that we'll do is that we will discover that. I've talked about the continuous assessment that we're doing. Not only that we will discover that, we'll assess that specific server that is now being deployed against the security policies that we have in place and help you understand what is its security posture of that specific server. And again, we do that continuously. More than that, in order to do that, actually, what we're doing is, and that's what you can see in the screenshot on the left, in this nice high-level architecture, we have agents in place that help us monitor these constantly changing VMs. Once these agents are in place, and that's, of course, how we can also support servers that are not necessarily in Azure, right, like, again, on-prem and other clouds as well. Once those agents are in place, we can run our advanced set of capabilities that we're now deep diving into. That also, of course, includes an extensive log collection that we're doing, not just for Windows servers, but also for Linux servers. So Azure Security Center supports servers from basically most of the flavors that are out there. And log collection, that's a big thing, right? Because if you want to make sure that you protect your servers, that you know exactly what's happening, which users are connecting, that you are able to detect attacks, you need to have logs in place. You don't need now, with Azure Security Center, to decide how those agents are going to be provisioned, which security events, which logs are going to be collected. Everything is being done automatically by Azure Security Center. And again, going back to the last point over here, for hybrid models, no matter where your servers are running. Server security hygiene. That's, of course, one of the, that's the first step, right, that you need to take in order to make sure that your servers are protected. How do you do that? With those recommendations that you get from Azure Security Center about baselines, configuration baselines that are misconfigured, about missing patches, about specific controls, network controls that are not necessarily applied or are applied in a secure manner. Everything here, that's part of the assessments that we're doing in Azure Security Center that eventually resolve in recommendations that you get. What we are seeing here in this screenshot, that's an example, and I'll also try to show that in the demo, of how this patch assessment is happening actually in Azure Security Center and the kind of view that you're getting when you're deep diving into that specific recommendation. And again, we need to remember, not just for Azure, and that's massive. Next capability that we have that's also considered as a foundation capability that you need to have for server protection, file integrity monitoring. And by the way, when I say we have this feature, we have that feature, it's all being available out of the box of Azure Security Center. So when you enable Azure Security Center, right, and that's basically a click, right, that's it. I'll show exactly how. When you enable Azure Security Center, all of those capabilities, all of this protection suite is there. Of course, you can decide what you want to enable, what you don't want to enable, but it's there, offered as part of the Azure Security Center set of capabilities. So again, file integrity monitoring, that helps you monitor changes to file and registry keys on your servers. Super, super important if you want to make sure which changes are being implied to your servers to make sure that you're on top of it all. So not only that we enable you to have this kind of control in place, we recommend you which files and registry keys should be monitored. We then provide you with the capabilities to manage those file integrity monitoring policies, to change them. Right? If you want to add custom rules, if you want to add wildcards, for example, you want to monitor a whole list of folders, right? You don't want to just monitor specific files. You can do that with Azure Security Center as part of the management capabilities that are available in our UI. But then again, of course, we also tie that to alerts that you get within Azure Security Center for those violations, right? For those changes that were detected by file integrity monitoring with Azure Security Center. So all of that is available as part of the Security Center platform. With that, and before I deep dive into the next set of capabilities that we have in the protection suite, I'll show a quick demo. Just a second. So while it loads up,
in presentation mode.
Oh, so let's quit that. Now it's working, right? Great. Yep. So that's Azure Security Center. In order to enable it, you can see it's part of the Azure platform. In order to enable it, you just need to look for this logo, for this green shield logo. It will appear in the Azure portal left navigation menu. It's there as part of the favorites pane. When you click on that, that's it. Azure Security Center is enabled, and it starts monitoring, it starts applying the security policies that are defined by Azure Security Center, and it starts assessing the environments. Again, IaaS, PaaS, servers, what's not. And what you can see here are the items that I've talked about. First, we can see how many subscriptions are currently covered by Azure Security Center, how many Azure subscriptions are covered, and in which tier. Whether they get the full advanced capabilities of Azure Security Center or they only get the basic. You can also see, and that's what we're showing here in the not covered part, you can see subscriptions that are being deployed in your tenant, right, in your AD tenant by your users, but those subscriptions were not registered to Azure Security Center at all. And that means that those subscriptions are not covered. And basically what the use case that comes to help with is shadow IT in Azure, right? Shadow IT subscriptions that are there, but you as a security organization, you're not familiar with them and you're not monitoring them at all. So that's about the covered part. I've talked about secure score, so this is how it looks like. You get a secure score over here. You can see what is the existing state and what is the maximum score you can get to based on the set of recommendations that are available in Azure Security Center. And just for server protection is this part, the compute and app section. So when you click on that, you can see servers, again, no matter where they were deployed, in Azure, on-prem, or other clouds. And you can also see the secure score impact for that specific recommendation. So for example, we can see that we have some recommendation here to apply disk encryption on this specific virtual machine. We can see that this is how it will improve the secure score. Some other recommendations about missing security solutions that we recommend to apply, or other controls that we recommend to have in place. And if you want to deep dive into a specific VM and understand, or server again, and understand exactly what its security state is, you can do that by clicking on the VMs and Computers tab, select a specific server, and you get the full information and visibility about its security state, whether it's monitored or not, and about the recommendations that apply just for that server. So that's about secure score and the recommendations. Last thing, first, another thing I want to show is the network map that I've shown in the screenshot that helps you get visibility into the network topology of your environment together with security overlays. On top of that, the map is fully interactive, right? You can expand nodes, you can close nodes. By default, we're showing only internet-facing nodes, but you can select to view all nodes that are available from all severities, and the map here will change. It's dynamic. What we can see now that it is clustered a lot of nodes together, because we want to make sure that you get the full value out of the map and that you are focused only on the nodes that require your most immediate attention, right? Of course, you can expand nodes in order to deep dive into other types of nodes as well. And of course, when you click on a specific node here on the graph, you get full information about it, including the recommendations that apply just to that. And of course, you can also deep dive into the traffic view to see which VMs can communicate with which VMs in Azure, through which ports and protocols by looking at the traffic area over here. And basically that comes to help you understand what is your existing network security configuration for Azure. Last thing I will show in this part of the demo is file integrity monitoring, which is available via the navigation menu of Azure Security Center, Advanced Cloud Defense section. You click on File Integrity Monitoring, and there you can see which workspaces. Azure Security Center is tightly integrated with Azure Log Analytics. Workspaces is basically the container, right, or the data warehouse for all of the data that is collected from the machines. And you can see which workspaces are already enabled with file integrity monitoring. Let me just zoom out a bit. And you can see which workspaces we recommend you to enable file integrity monitoring on. And when you will select a specific workspace, you will see all of the changes that were detected by Azure Security Center, which machines are currently protected by that. You can see actually the full list of changes, deep dive into a specific one, then cross-query it in Azure Log Analytics because of this tight integration, and that's super powerful. With that, let's go back to the slide deck. Adaptive application controls. How many of you already have implemented today an application whitelisting solution on your server environments? Not a lot of hands. Okay. What I will tell you is that when you think about server environments, right, compared to workstation, an application whitelisting solution is actually considered as one of the best solutions that you can implement. And the reason for that, and by the way, we're not the only one saying that. You can also read about it from a lot of the large research companies out there. When you think about server environments do not supposed to change, right? They usually serve a very dedicated purpose. Because of that, usually, and actually most of the time, those servers will run a very close set of applications that won't change. And when you think about it like that, you obviously agree that an application whitelisting solution is ideal for such environments, right? Because when you enable it and you decide to focus only on the set of specific applications that need to be allowed on those servers, basically any other application that will try to run will either be audited, right, depend on the enforcement mode that is currently enabled, or that it will simply be blocked, right, if it's not allowed. What we're doing with this feature, with adaptive application controls, that's an end-to-end automated application whitelisting solution from Azure Security Center. And what does that mean with this bombastic introduction that I've just said? We learn which applications actually are being used on every server that you have. Windows Server, currently it's only supported for Windows servers, that's important. We learn which applications are being used on every server. Then we also learn who are the users that are running those applications. We understand if a specific server environment is a good candidate for an application whitelisting solution or not, because we don't want to create a lot of noise in your environment. After that comes an automated clustering mechanism, because one of the biggest challenges with application whitelisting solutions, if you're familiar with that, is manageability. How do you manage those policies? How do you make sure that you have the right policies in place per server environment that you have? So we cluster similar machines together based on their behavior, based on the applications that are running, based off of the users that are connecting to those machines and are running those specific applications. And then we create tailored application whitelisting policies recommendations. That's how it's surfaced up in Azure Security Center. We recommend you, hey, these are the policies that you need to apply for this set of virtual machines. These are other policies and applications that you need to allow for those type of servers. But we don't stop there. Once our users review those recommendations and approve them, of course, we don't currently do that automatically, we will automatically apply those application whitelisting policies for our customers, right? So it takes all of that burden away as well, of creating the rules, understanding how they need to be created, whether or not they're applied or not. Everything is being applied automatically by Azure Security Center and by default in audit mode, because we don't want to start blocking anything right from scratch, right? We want to make sure that our users are satisfied with this solution, that it really fits their needs, it does not create a lot of noise. But then, once those rules are in place, and that's what you're seeing here in this screenshot, we also provide with the full manageability experience to change the protection mode. For example, to move that from auditing to enforce, to remove some rules if they are unnecessary, to add custom rules, to change the list of allowed users per applications. And again, all you need to do, that's sort of a configuration page, right? But once you finish that and you click on save, when you click on apply those specific changes, Security Center will take all of those changes, all of these new policies that you now want to apply, and do that automatically for you. And that's huge, right? Next thing I want to talk about, of course, we operate in cloud environments, so we have the advantages of a lot of cloud-native tools, cloud-native controls. For example, we have visibility, traffic that comes in and out of the Azure platform. We can use that visibility in order to provide very accurate threat detection alerts based on that traffic analysis. That's something that only us as cloud providers have visibility to. More than that, one of the best capabilities and best features that we have, and that's the second bullet, just-in-time VM access. One of the things that we're seeing with customers that move their workloads to Azure, or actually to any cloud environment, they usually leave management ports open. Why is that? Because they want to administrate the machines. So they leave the RDP ports open, they leave the SSH ports open, but it's not limited just to management ports, right? That's also relevant for any other port and also for internal traffic as well. What we're doing with just-in-time VM access are two things. First, we enable the customers, we enable our users to lock down specific ports 24/7. So it's a network-based just-in-time solution. It's not a role elevation, right? We enable our customers to lock down specific ports, for example, lock down RDP port, but then we also provide the means to open that specific port on demand for a limited amount of time and only for authorized users. That's massive. That reduces the attack surface like dramatically. We're seeing customers of us that used to have like brute force attacks, hundreds and thousands of brute force attacks and port scanning attacks and spam attacks and whatnot per day going to zero. Zero, right? Simply because the ports are not available. That's massive. So that's about just-in-time VM access, a new capability that we've introduced 2 days ago during this conference, adaptive network controls, similar to what we're doing with application whitelisting, where we learn the patterns, we create recommendations for policies. Now we're also doing that for north-south, that's internet, inbound and outgoing traffic to servers that are in Azure, in order to help you better harden your network security groups, better harden the rules, right? So that means that we come up with a set of recommendations for policies. Later on, because that's currently in limited public preview, we'll also automatically enforce those rules for you if you choose to do so. We create recommendations for the set of rules that need to be applied per VM and per port, based on an analysis of the traffic that we're doing, where we identify legitimate communication patterns. We combine that with the massive threat intelligence pipeline that we have, threat intelligence reports, in order to remove IP addresses and IP ranges that are tagged as malicious or also as suspicious. And of course, because we have this visibility to all of the traffic that comes in and out of the Azure platform, we use sophisticated clustering mechanisms to compare our recommendations, right? To make sure that they are accurate, in order to make sure that those policies really fit the specific customer environment. Let's go back to a demo. So I'll start with adaptive application controls with the application whitelisting solution. That's available via the left navigation menu from this part over here. Once you click on that, you see which groups of machines, and you can see that these groups of machines were automatically created, right, are currently configured, and which groups of machines are currently recommended. Once you click on a specific group, you can see the full list of VMs that are part of this group, including the specific applications and users that we recommend to whitelist. You can also get visibility in some more applications that we have identified to be running on these machines that we have learned that are there, but we don't necessarily recommend to allow them. And the reason for that can be maybe because we have some threat intelligence information about them, or that we identify that those specific applications are not that common on those set of machines. So we recommend you to review those. And once you click on the Create button over here, Azure Security Center, as I've said, will automatically apply the rules on those servers, making sure that the application whitelisting policies are applied and effective. Later on, of course, I've talked about the full manageability experience. If you want to go to a specific group and change a specific configuration, you can play with the protection mode. You can move that from enforcement to auditing or vice versa. You can extend the policy and add custom applications. You can see which rules are currently applied and maybe remove some or change some. And of course, as I've said, when you save it all, it will automatically be taken by Azure Security Center and applied to all of the relevant virtual machines and servers. Next thing we're going to do, let's look on just-in-time VM access. It's currently available from this area over here, just-in-time VM access. One of the things that I can share is that it's also going to be available from the VM blade in Azure. When you select the connect option and you can get the RDP client information or the SSH information, it's also going to be integrated there. But currently it's here. And when you go to just-in-time VM access, you can see which VMs, again, are currently configured with this control, which are recommended. When you select to apply JIT on a specific VM, you can see that by default, we recommend to apply it on management ports. You can play with the configuration per port. For example, what is the maximum amount of time for which you allow to open that specific port. You can also add your own custom ports, and that's also something that we're seeing in some of our customer environments. For example, when they apply good security practices and change the RDP, the available RDP port from 3389 to another port, so they can use this specific configuration place in order to add custom policies as well. When a specific VM is currently configured and is protected, that means that those ports will not be available right now, right? They're closed. So if I will now try to RDP to a machine that is configured with JIT, I will be blocked. I will see that I have a session timeout. I'm not getting any response from the machine because the port is closed. But let's say now I want to open the specific port. I want to connect to the machine. I go here, I select the specific VM, click on request access. I select the port I want to open. Let's say I want to open it only to my IP, and for 1 hour. I will click on open ports. Now what will Security Center will do? It will assess whether or not I'm authorized to open that specific port. And that's documented, and of course, you're welcome to ask me after this session how this is being done. And once it is approved, RDP is now available to my user, right, coming from this IP. And after this 1 hour time will end, Azure Security Center will again make sure that the RDP port will be closed. That's powerful. With that, let's go back to the slide deck. Last but not least, of course, we're talking about all of these advanced capabilities that we have in Azure Security Center that helps you assess your environment, understand what it is security posture, right? Policy management, recommendations, all of the advanced stuff like JIT, application whitelisting, file integrity monitoring. But then we also have a very rich offering for threat detection. That's one part of the better together that we now have also with Windows Defender ATP for Windows servers. So first, of course, we leverage all of the massive threat intelligence information and reports that we have inside Microsoft in order to help our customers understand if their environments are being, for example, attacked by known malicious IP addresses, by specific CNC servers that are already tagged by our threat intelligence reports. We use advanced analytics that involves anomaly detection and behavioral analytics that leverages all of the information that we collect from the machine, the security events, the audit logs from Linux servers, the traffic analysis that we're doing in order to provide with accurate and advanced threat detection capabilities for both Windows and Linux servers. That's important to emphasize. One more thing is about Fusion. We have our own automatic correlation engine where we take all of those signals, all of those alerts that we get into Azure Security Center, and we automatically combine them. We automatically create a new object of an alert that we've identified in the environment, which we call an incident. And the incident really helps our customers to understand the full attack campaign story. How a specific alert that is related to another alert came to materialize and has now compromised the environment. And let's think of the next use case, why it's so important. I'm talking to customers every week, right? To very large enterprises every week. They have hundreds of alerts per day, per week. Let's say, what do you do with the low severity alerts? Right, I'm always asking them. And they simply don't have the time or the resources to get those alerts because they're always very busy and occupied with the high severity alerts. But what if you have an engine like Fusion that takes multiple low severity alerts, connect them together, right? And you may be able to prevent the attack from materializing simply because you're looking on those low severity alerts. You're not waiting for the high severity alert to come. So when those low severity alerts are connected together, they're now focusing the SOC and the analyst on other types of attacks that may usually be neglected. And that's super, super powerful. And of course, the integration that we now have, that's GA with Windows Defender ATP, which is the best EDR solution in the market, now available for servers as well. With that, I'll hand off to Tzvi.
So sorry, I was moving back and forth. I was trying not to fall asleep. Okay. As we said, we GA'd the Windows Defender Advanced Threat Protection for servers. A few words about what we offer in terms of endpoint protection. When I say endpoint protection, this includes servers and clients. It includes Macs and Linux through partners as well. So we enable a full EPP plus EDR, so preventive capabilities plus post-breach capabilities on your endpoint for the entire estate that you have. Today we'll concentrate on servers, but we'll also see through the demo that we'll have a very important integration of having a single pane of view of servers and clients together when we're trying to look at an attack. Because to get to a server, most likely, most of the times, unless you have a very unsecure server internet facing, you will get through it to a client. There will be some kind of a credential theft. There will be a reach out from a client on your network into the server. You usually don't have a finance server with important information externalized to the internet. So I will compromise a client by social engineering or very expensive 0 days, or both of them usually together. I'll get credentials and I'll get to the server. So Azure Security Center will alert you the server was compromised. But if you want to stitch the story, how did they get on the server? You need visibility to your entire state. And a lot of the times is via a client. So the holy grail, I think, of an attacker is usually to get to the server, but he has to get in somewhere. What do we offer on that full stack? And I'll kind of give you on that. So we offer attack surface reduction capabilities. This is going to be available in Server 2019. This is a lot of controls that you can actually run on the server built in to allow you to reduce the attack server. And they will be exposed in Azure Security Center in terms of you didn't enable them or you did. We're enabled to run ASR rules in audit mode first, so you can get all the hits on them. And again, you can act like if you want a baseline of recommendation of the ones you can actually close. There's stuff that you basically shouldn't be able to run on servers. Not just in terms of an application, but I don't know, should macros run enough? Probably not, okay? There's all kind of things that you should probably not allow on your server. Should Office applications, for some reason, create a child process or try to communicate with external IP? So there's a lot of things you can actually limit on that, and by that, again, hardening your environment. Next generation protection is our next generation AV, based on machine learning, AI on the client itself. You get it on the server. There was no need today to run a third-party AV on your servers. If you're running Windows servers, you have Windows Defender NGAV running on the box. And that's fully integrated into that suite. We will see detections of the AV, but we can also use that integration to the on-box AV to do all kind of scenarios like block scenarios, right? We can ask it to stop something from running. We can do remediation actions through that integration. What we will show today is the integration into EDR. EDR is a flight recorder if you want. We build it to be not too smart in terms of the logic that it's doing on the box for two reasons. Very lightweight on your CPU, it doesn't have to make decisions. And also so you can't tamper with its logic. Please record everything that we define that you need to record and send it up. We will analyze that in the cloud and we'll look for indications of attack. We have indications, we classify them into two. Indications of compromise, IOCs. It's the easier part of the parallelogram. It works, you always need it. If there is a known indicator of attack, a bad file, a bad IP, you can increment it and you can give a certainty of 100% that this was a bad thing. Indications of attack, a little bit more complicated. These are generalized rules that try to look at an attack vector and say that something looks similar to. Not because it's similar to a file, not because it's similar to an infrastructure we're connecting to, because it has behavior that looks the same. It's quite a complex problem to solve, but if you use a very good baseline or machine learning, you can look at that. And you'll see here in the demo a suspicious code injection memory injection into another process. That you can do only with machine learning. Why? Because as you create a baseline, you learn what is the baseline that one process injects into another, and if you look at the baseline of the entire world, you can actually understand what looks normal, and I never saw that before, okay? In our case, we will see here, I think, PowerShell inject into Notepad. Why? Okay, so it's an anomaly. It doesn't usually happen. Or even if you have stuff that does inject into another, maybe it does a memory allocation, which is out of bound, because they usually have something. But by applying a very large set of machine learning, you can create these alerts. So that's EDR. It's a lot of data going into the cloud, being analyzed and compared into big data sets using IOAs and IOCs to try and find the bad things. Automation. Automation we currently have deployed on client. Server will be coming. Server is a different problem set to solve in terms of automation, because automation is also capability to auto-remediate. And auto-remediate on a server is something more sensitive. So it's another problem set we need to think of. So we address first clients, where you can actually completely do if you want an IR playbook on that endpoint, and then investigate artifacts, find something, incriminate. So assume you investigate a machine, and during that investigation, you found out that there's a bad IP that was communicated. You can now go and search the entire organization for that IP connection, and then incriminate 2 more machines, and then go play repeat. Go the same automation process on the same machine, scan all the processes that run, scan all the drivers that have been loaded. Is there any vulnerability that was loaded? Check for about, I think we checked for about 53 different persistent methods. Does any persistence try to happen on the machine? All the IP communication, is something out of bound compared to the baseline. Try to analyze a lot of things, the user integrity. Query Azure ATP to see the integrity state of the user. Was the user compromised in terms of identity? Did he log in from 2 time zones in the same time? Compare all that, and then tell you that the machine is okay. This will move into server. Security poster is secure score, and I will show that. It looks a little bit different when you're trying to look on an endpoint in terms of machine, because all these security measures, the ASR rules, the EDR sensor, all our capabilities, it measures your endpoint and server against that. Have you applied all the capabilities that are coming out of Windows, out of the box? Have you used all of them to protect your server? And finally, advanced hunting. Advanced hunting is advanced capabilities for SOC analysts to actually take all the data that we collect. We give you that data back in a very organized schema, but we give you the entire raw data in a very fast elastic search that you can actually search on top of that. So if you think of the logic, and I'll show that in the demo, I'm investigating something, and at some point I will find that single IOC or something that maybe it's a command line specifically run from with some arguments, and I can search for that very specific artifact across my entire org to see if that happened again. That not necessarily that was exposed by an alert, but me during the investigation can start finding very specific indicators. And the nice thing with advanced hunting now is because we have a Git repository for people to actually post queries, then you can start sharing with community, and as attacks unfold and things become common, you will see people, they're posting into that Git and say, hey, run that, I discovered that in my environment. You don't have to say the name of the company and that. If you run that, that will expose basically that thing, and we are learning from each other about all kind of queries we can do. It's a very powerful tool that's evolving. So, the integration part of Windows Defender into Azure Security Center. The onboarding of Windows Defender Advanced Threat Protection onto a server is done automatically. The moment you add your server into Azure Security Center, it will enable the EDR component. Okay? It will not turn and configure all your ASR rules automatically. The AV is your decision if you want to put there. But the EDR sensor, all that information that I'll show you on the dashboard, it's turned on automatically for you. There's no work to done. Everything is done in the background. For 2019, it's out of the box. For all the server versions, it's actually installed an agent. But all that's done is for you, including enabling the portal that I will show you, and your credentials and your ability to actually go in and do all the investigation. The single the second thing is what I said before, is having that single pane of view across servers and clients. Okay, you will see that very powerful server, clients, Macs. You see the entire environment, mobile devices, because attacks sometimes move across these properties, and seeing them in a silo sometimes doesn't give you the full picture. And what we'll show in the demo is the detailed machine learning investigation, the hunting tools, all your capabilities to actually triage the alert. So we'll do a demo. I'll show you how an alert is discovered in Azure Security Center with signals that are coming from the endpoint, and then how we discovered there's another client that was involved, how we pivot between the server and the client, understand there's a single identity, and see the attack actually unfolding across that. It's good.
Okay, so going back to Azure Security Center and building on what Tzvi has just said, by default, when Azure Security Center is enabled, part of the protection suite is that you get Windows Defender ATP out of the box for VMs that are monitored by Azure Security Center, also for servers. Again, no matter where they run, on-prem, cross-cloud, or in Azure. As long as they are protected by Azure Security Center, they are monitored by Azure Security Center, and they get Windows Defender ATP out of the box with that. And how does it look like? So we've talked about the threat detection capabilities that we have across IaaS and PaaS and all. And it all shows up in the threat protection area of Azure Security Center. And what we can see here is a specific demo environment that we've created for this session, where we are seeing an alert on a server, right? Because Azure Security Center is the infrastructure security solution. So we're seeing an alert on a server that has been detected by the Windows and Defender ATP EDR component that is now integrated with Azure Security Center. So the first place that you will see this alert, together of course with more types of alert that will also involve the fusion that I was talking about and all, that's in the security alert section in Azure Security Center that is available either from the main dashboard that I've just clicked on or from clicking on security alerts over here. And once you get to that, let me just zoom in a bit. You see the full list of alerts that were detected by Azure Security Center. And this is the alert that we'll now focus on. We see unexpected behavior that was observed by process run with no command line arguments. And we see that it involves a specific server. We've identified two types of alerts for that specific server. When we will click on that specific server that we want to deep dive into, and again, this flow that I'm currently showing is also available for any other type of alert that is detected by Azure Security Center or is available in Azure Security Center. Again, for IaaS, PaaS, no matter what service is protected by Azure Security Center. You get first full information about the alert, including full description and remediation steps that you can see below, right? And in this case, I would also like to deep dive into the investigation of that specific alert. So I will click here on the investigation area. And when I click on that, I go through the investigation experience that is also available as part of Azure Security Center. That's an investigation graph, right? That helps you to understand how the specific entities are related to each other, starting from that specific alert that we're starting with. But of course, you can use this graph in order to identify more types of alerts and more types of entities like other users, other computers that are monitored, or servers that are servers that are monitored by Azure Security Center. And again, of course, you can get the full information about this alert. So we're seeing that this specific alert that we're starting with was detected by Windows Defender ATP. Right, and we can see that there is some user and computer that are directly related to that alert, some Ingrid Wyatt user, and there is also some laptop that is involved with Ingrid Wyatt. We'll deep dive into that probably in Windows Defender ATP, right, because these two solutions are now tightly integrated. And now this is being done. Within that specific alert, you see the alert provider link. When you click on that, you're immediately being redirected for deep dive and hunting in the Windows Defender ATP portal. And again, this whole registration of both of the solution, this integration, is offered out of the box and is being done in an automatic fashion as part of the registration to the Azure Security Center service. With that,
So you landed in the Windows Defender Security Center, which is basically for the SecOps will be kind of the first place they will land on looking at specific alert. We have 7 ways to pivot around the information. We have an alert entity, we had a machine entity, a file entity, an IP entity, a user entity. So when you're pivoting and trying to triage an alert, these entities are very helpful. But the first place, and as you see, I did make it up. It doesn't support automation on that OS yet, but it will go away. We give you kind of a first, if you want, alert process tree, because the deep insights that we have into the OS, which allow us to see what is calling what is the process tree, basically tell you that we had here PowerShell that actually spun Notepad, and Notepad communicated with some external IP. So this is kind of a very fast way to understand that something happened here, okay? There was a script happened here, PowerShell asked Notepad to run, and Notepad communicated with an IP. Since when Notepad does that? Okay, so we want to maybe deep dive into that. There's more here that tells me that there's other machines involved here. Okay, there's other users involved, there's other machines, and the connecting dot in that investigation was that all of them communicated with that IP. Okay, that's if you want, sometimes you need to have something to pivot off in order to be able to stitch things together and say this is, so either it's a user that was incriminated and then all the machines that are connected to that user. In this case, it was an IP. And we'll go and look into the Alice laptop, that user's laptop, and try to understand what happened here. And when we look at the laptop, we will see, where's the alerts? It's coming, okay. It was a weird interface. We'll see that we have 2 alerts, actually. So one was the same alert that we saw on the server, right? A process run, normal process behavior of running with no command line. I don't think the command line thing here, thing is here that it's actually communicate with IP. Why would Notepad actually communicate? And when we look at that, oh, we're zoomed in, that's why. Okay. When we look into that, we see these 2 alerts. This is if you want your deep view timeline into everything that's happening on the machine. You can filter that into a verbose mode and get everything that we see. This is a behavioral mode, which means we only show you indications of stuff that led to an alert. So all the behaviors we found on the box that created an alert. The alert is, if you want, the summary of this and this and this together, indication of alert. So there was something that happened here before that unsuspected behavior observed by a process. So let's try to understand what happened here. And if we look here, we see there is a suspicious process injection observed. This is code injection from one process to another. In this case, we'll give you the full tree of what this actually did, okay? So think about the amount of work you need to do in a SecOps to actually try to log on that, cross-correlating logs, cross-correlating memory dumps, and try to understand that was a process here that injected. This is powered by the machine baseline telling you that usually we don't see PowerShell injecting something into Notepad, but not in this case, and popping that alert. We tell you where that happened. If you actually go and click here, you can always get a little bit more information, the injection timeline, and more information specifically. The SHA-1 of Notepad is not very exciting, and it's kind of a known executable. Let's see the unsuspected behavior. So we'll go next and we try to understand what was weird about this thing, and we get the IP that was communicated. Okay? So you get it kind of very quickly without doing any hunting on raw logs and data. We were able to get to a conclusion. We understood that something happened here. Okay? There's someone on the box, code injected under that user privileges. We don't have the full scope of how we were able to achieve that. There was a privilege escalation, probably allowing PowerShell to probably do that injection. And then we have Notepad communicated to a bad IP, and we see that bad IP communicated in other places. I just show you some more properties that you can do. An IP has its own page. This one is our infrastructure, but if it was so on an IP page, because you're pivoting, you will get information like what we can tell you. about that, but assume that was a real bad command and control, a fresh brought up infrastructure. If we have any reputation we can pull out of security graph, out of Bing, to tell you something about that, we'll let you know. If we have anything in our threat information, we'll actually augment that data and tell you we know this is bad. If we're even lucky, maybe we can tie it to a specific actor if we have that. But this, let's say the attacker is very good, it's a freshly made or maybe even compromise a very known domain. So we won't have anything here, but you get all that information, everything we can tell, but we can also tell you all the alerts that we can tie back to that. And they can be on different machines. And that's where the IP is able to connect. In the same way, we can go and look at a user entity. So we can see that was logged into 4 machines. There is all kind of alerts tied to this user. We had 2 different alerts on another server. There's a third. This is the server on the bottom that we just looked at. We played with that before, so we kind of already did resolved on 2 of them, so they're grayed out, but we have 3 new things. So that user is now creating alerts on all kind of other machines, and you're trying to stitch, what do I know now? After a few minutes, I know what's the user that has been compromised, and I know that it's been on 2 servers on a machine, and all of them being communicated to a CNC somewhere out of my organization. See if I covered the machine view. Let's look at that as well. Alice laptop. So a machine also have a lot of set of information that you can actually get out of it. The entire timeline of the machine. You can do a time travel on the machine back and forth. Some attacks don't all happen in that little window. They started very, very long time ago. Then it was dormant for a while, and then someone woke something up. So we store 6 months of data in the cloud for you to go back in the time. We will store the data even the machine was wiped and not there. We will run our IOAs on your machine timelines, on everything that's on your estate. If we found a new indication of attack or a new rule that we're running, we'll run it retroactive on all your estate. We may tell you 4 months ago, this attack vector that we now learned about is run on that machine. Hopefully we can do that in real time, but it's also good to know at retrospect that something bad is run. I had a customer not long ago, we found that was an EDU kind of type of customer. This machine of the person, the staff, is not even on the university anymore, but that was a compromise, which was 4 months ago. But everything is saved you for that in the timeline. There is no investment on infrastructure like in Azure. Everything is managed for you. It all comes out of the subscription. I wanted to show you advanced hunting tools. So you understand that. And it's a very small environment. So I had to go before and say, okay, what kind of queries can I do? This is basically, if you want, we had here network communication, for example, right? So we had something here to do with IP and network communication. We will expose the entire data set of everything that we can collect that created all these alerts, that created the machine timeline, and let you actually run through them. So how does a query look? I build a query here to say, I understood that the IP is the pivot, and yes, I have all these nice graphs, but still, I want to run maybe something a little bit different. I want to expand the timeline. I want to communicate it with this. I want everything that communicate with that IP here. I set it to 1 day ago. Okay, don't give me all the machines because I just incriminated that, and I want to know what happened in the last hour. So this is a 1 day ago, and I can run it. I won't give everything back because the attack was done probably longer than 1 day ago. So let's put 60 days ago. Save it. Okay, and I got a result set of all the machines that communicated with that IP. So that's kind of a very basic query, but I can become really fancy with that. I can go for a specific runtime executable with a specific command line argument in a specific environment, in a windows of time, within a specific user scope. You can build very, very elaborate scopes. I saw stuff as customers ask me, how do I know that a lot of data was dumped into a thumb drive, okay? And McAfee has this capability out of the box. Run a query. Run a query on all files written that's something that's not your disk. It's not D or whatever, how you map your files in an organization, that has more than 50 files written in less than this time, and then let it run every day. Something we added here now is a capability to schedule these queries, which is basically, if you think about it, allowing you to write your own detections. Because you can say, this is something that I'm looking for, and I want you to run it every day, and give me an alert in case you find something like that. And it will be, you can tie it to an alert. You can say, if this runs and gets a hit, then I want an alert on my timeline. And since we are integrated into Azure, you will get that alert on your Azure Security Center. So you can say, on my servers, that a very strict environment, I do not allow something to run in a specific way. Please look for that indicator. If you see that, I want an alert. So I mentioned a few more, only 9 minutes. Okay, we wanted to leave time for questions. So I will do 2 more things. Secure Score was, as I said, the same thing, but very focused on what you have built into Windows Server and ability, or Windows Client and ability to actually play with these controls. Have you applied all the right controls? And something we just added, we announced this, is threat analytics. Threat analytics, if you want, is our research team, together with the research team that defends Azure, together with the research team defends Microsoft properties, together with the research team from Office and Windows. We have a collaborative team that will build this information, which is basically, think about it, your CISO, your CEO just read in the news that there is something new called dangerous snake, and you get a phone call and it says, are we good? This is not only a description of all the artifacts of this attack and what we learned about it, what we can tell you, this actually maps it against your environment. So this is a one server environment here. So you're not going to get a lot of data. Okay, there's one machine and that machine is mitigated. But in 100K endpoints, mixed environment between servers, Macs, Linux, it will tell you that 80% of your state is good because you're on Windows 10, latest, most current. You have another 20% which has a problem. It's server 2003, but it has nothing, not only with the versions and patches, we can tell you that this attack vector is using a specific method to get in, and you're not mitigating. There is an ASR rule there, or there is something you can do on the server to harden, or maybe you can even just close a port that allow you to actually, if you want to call it the virtual patch, right? So you, instead of really before going and fixing, there is a mitigation here. You can stop that vector by just closing Samba in your organization for now, okay? Something like that. We need to leave time for questions. Well,
yeah, of course.
We wanted to leave 15, but
so right
the last session, right? So we can stay.
So right before we finish, let's just recap, right, on all of we've talked about in the last hour and almost 15 minutes. So infrastructure security is being done with Azure Security Center that spans across IaaS and PaaS, servers and Azure services that you can consume, across these 3 pillars of security posture management and assessment, protecting against advanced threats with both preventive capabilities and threat detection capabilities. That also includes the integration that we now have with Windows Defender ATP. And of course, everything is being done in cloud speed. You don't need to be a big security expert in order to use this protection suite. Mostly it's being done automatically, including discovery of the resources and the servers that you have, making sure that they are protected and that the policies are in place and that threats are being detected on time with full information and description about that. And we now, and that's basically the main agenda for this talk, is the better together that we have now with Windows Defender ATP that enables you to harness both platforms' capabilities, right? So with that, we invite you to take actions today. Security Center has a free trial for 60 days where you can use all of the advanced capabilities that we've talked about for both servers and services. This includes application whitelisting, just-in-time, the advanced network controls, the network map, the Windows Defender ATP integration, the Microsoft Cloud App Security integration, all of the threat detection pillar that will develop even internally in our team. You can try that right now after this session. Just enable Azure Security Center for free for 60 days. I promise you, you'll love it. And it's really easy to use. As I've said, get secure faster. You don't need to be a big security expert in order to understand how to work with this product. And with that, with exactly 5 minutes and 20 seconds, we would like to thank you and to leave some time for questions. There are mics here if you prefer, or you can ask us and we'll repeat the question to the crowd.
About ATA, who's at version 1.9, what its role is moving forward and how it plays with Azure Security.
What was the question about? I'm sorry.
Analytics, which is at version 1.9, right, the most recent release. What is its play moving forward?
How do you connect ATA into...
Great. So currently there's already an integration in place, right, with Azure ATP. Alerts that are detected by Azure ATP and are focused on identity, right, on the identity domain. You went through, if you went through the M365 stories with identity, applications, devices, and infrastructure. So Azure ATP is the identity piece of that. And that's tightly integrated with Azure Security Center. So alerts that are detected by Azure ATP, if you choose to connect it to ASE, you will see its alerts there as well.
Sorry, but what about ATA specifically, which is monitoring your domain controller activity?
There's Azure ATP is the ATA in the cloud.
Exactly.
If you want.
It's a SaaS ATA.
These are cloud applications. You need to enable that capability into the cloud of ATA, which is
Correct.
Azure ATP, in order to create that integration. It's an enablement. It's a, okay?
You can, if you want.
Only on-prem,
On-prem.
it will not talk with that. If you have the only on-prem solution, you didn't enable Azure ATP, it will not talk with that.
Exactly, yeah. You can connect the alerts, but it's more complicated than that. It's not an easy integration.
Check. But it's also not a very complex way for you to go from an on-prem into enabling the AATP
Correct.
capabilities.
Correct.
Okay, it's not another service, it's an extension of that. But that's another session. Expanding your ATP into AATP.
To the cloud.
Yeah.
Any more questions? Yeah, question at the back. Sorry.
Hello? Is this on? Yeah, okay. My question was, can we use some of these features like the file integrity monitoring for systems that are not in the Azure space and or maybe not on a Microsoft operating system?
Sure. So the question is yes. As I've said, Azure...
Can you repeat this question?
I thought everyone heard that. Sure. So the question was whether or not some of the features, specifically we're asking about file integrity monitoring, if it's also supported on servers not in Azure, right? So the question is yes. As I've said, Azure Security Center supports hybrid workloads. So no matter where the server is being run, Azure, AWS, GCP, on-prem, as long as you have, and if you recall the architecture screenshot that we had there, once our agent is in place, you can get file integrity monitoring from Azure Security Center for that server. So yes, Azure Security Center is the server protection suite from us, from Microsoft.
Question around the implementation of Windows Server 2016 versus 2019. So with Windows Server 2016, I believe the ATP capability is enabled with the MMA agent.
Correct.
And so is that basically integrated into Windows Server 2019, or what's the difference there?
In 2019, we already built into the OS like we have in Windows 10. So we're already part of, the code is compiled with that.
Like
so
Windows
there's no
10.
agent to install. It's
Yeah.
enabling the service, but it's already, the binaries on the box.
Right.
With 2.16, you have to have the binaries on the
Right.
box.
So it's
we go
basically like Windows 10 now,
yes,
which is
yes,
already there.
it's out of the box.
Yes.
And the other question was regarding Fusion, the Fusion engine versus the ATP console. I've noticed that in Fusion you can do investigations. So what's the differentiation there? And yeah, so it's a little confusing because there's two consoles of doing investigation. So is the focus like if you want to go deeper to go into ATP, And then if you just want to keep high level, you stay in the Fusion console? What's the
So,
strategy
so
there?
there, I'll start and then
Go
I'll
ahead.
hand it to you. So Azure Security Center, as I said, we're focused on infrastructure security, right? So that means that we're more focused on threat detection alerts for servers and for Azure services, right? If you want to take those server alerts that are being generated by Windows Defender ATP and maybe try to learn about a bigger attack campaign and how it also involves the workstations that are involved, you will do the deep dive and threat hunting with the Windows Defender ATP console.
The Azure Security Center brings you alert. You will see there is alert provider if you want. And some of the time it will be the network, what's happening in the network that Azure Security Center is monitoring, what's happening in the applications. So the provider will not be Windows Defender Advanced Protection. If the provider is Windows Defender Advanced Protection, you have more data on that portal. That's where you go deep in, but not always that will be the interface. I think the other places, if you want to try and understand, like we said, across the state, okay, so I saw the alert on the server, but how did they get to the server? There was nothing. This server doesn't connect to the internet. How do I have an alert on it? Then you probably want to go into Windows Defender ATP and look at how am I looking at the entire state and what's happening there. So
Actually, it depends on the use case that you're trying to investigate.
Yeah.
And to go back to the first question about the MMA agent, with Windows Server 2016 today, you have to enable the extension for anti-malware and the MMA. It's not needed at all in 2019?
It's provisioned automatically by Azure Security Center.
Right.
Yeah.
So is that the same case at 2019, or it's also the Windows Defender capability already in there, and you don't have to
it's
enable
enabled
the
because
extension?
instead of doing the install of the enabling the agent, to actually just do the configuration and turn it on.
The Windows Defender ATP part of it is enabled by, as Tzvi said, by default, right? Part of the OS. But the Microsoft monitoring agent is still needed from Azure Security Center in order to get the complementary capabilities of FIM, of adaptive application controls, of other threat detection capabilities that we have from other integrations that we have in place. So both are needed. In the backstage, the integration between Windows Defender ATP and Azure Security Center is the same. Right, so the alerts that are detected by the EDR component are still being surfaced in Azure Security Center.
Okay, gotcha. Thank you.
Sure. Yeah. The question was when the preview features are going to be available. Which specific preview features? So most of the features I've talked about are GA, already and available today, such as the integration with Windows Defender ATP, such as file integrity monitoring, such as threat detection that we're doing for Linux. Some of the features that I've talked about, like network map, for example, with the network topology view with security insights, that's also available for all of our customers, but it's in public preview, it's not GA. So it's going to be GA in like a couple of months. That's the plan. Yeah.
Yeah, you can enable beta features on all our products, and then you get kind of what's in the public preview.
Yeah. Oh, that's a long time ago. It's GA. It's a GA feature.
Yeah.
So we have a limited public preview for adaptive network controls, not application whitelisting. I understand the naming is a little confusing. Let's put it like that. It's the network-focused feature. You need to register via the Azure Security Center UI. You have a link there to fill a form, and we'll basically enable it like within a day or so. So, yeah. There's a question.
Hey guys, one of the things that you mentioned and that we run into as well is managing multiple AV vendors. Is there a roadmap or a plan for a Defender AV for Linux?
Currently, we don't have a plan for that.
Okay.
We're working through partnership. So we have 3 partners currently that support Linux. So you could get all that view in the WDTP dashboard, reporting into Azure Security Center. We are Ziften, Bitdefender, or SentinelOne.
Just a question back to you. Were you referring to workstations or servers?
Probably one.
Servers.
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 Linux.
So I'll just add that on Linux servers, we have our own component from Azure Security Center that has a very extensive set of threat detection capabilities for Linux servers. We develop it internally as part of the Azure Security Center product team.
That's the like the host monitoring.
Yeah.
Okay.
Yeah. Any more questions? Thank you very much.